We're going to solve some problems using the law of conservation of momentum. In order to use the law of conservation of momentum, you have to understand what it means. All of the momentum before the collision equals all of the momentum after the collision. This law applies to every single type of collision, from an inelastic collision where two things stick together, to an explosion where two things separate after starting as one object, to things hitting each other and bouncing apart, to things colliding and then moving to get kind of at the same direction but at different speeds. So there can be all sorts of collisions. And there's only one law of conservation of momentum. The initial side is the moment right before the collision, and the after side is right after the collision. So we don't care what happens 10 minutes later or after it slides. It's the moment before and the moment after the collision. So let's do 4 guided practice problems, and we're going to be using the same law, right? The same expression. This could have many parts, but we're generally going to deal with just 2 objects colliding. But just know that it could apply if you had 10 objects colliding. So a ball moving 5 meters per second to the left strikes a second ball initially at rest. After the collision, the second ball moves at 2 meters per second to the left. What's the velocity of the original ball? The first thing that you absolutely have to do is draw and label a sketch. So I've already drawn the sketch, and I always start by labeling M1, V1, V1 final, and M2, V2, and V2 final, so that I have all of my data in a nice, neat list. So it says a ball moving 5 meters per second to the left. So this is 5 meters per second. Strikes a second ball initially is at rest. After the collision, the second ball moves 2 meters per second to the left. So this is ball number 2. This is ball number 1. I guess I labeled those wrong, right? And it says, what's the velocity of the original ball? So the final velocity of the original ball right here. This is what we're looking for. Now, you're not given any masses, so we're going to assume that they're identical, okay? So we're just going to call this M and this M. All right, what happens when we don't know the mass? Generally, it cancels, but let's take this as far as we can. The next thing that you have to do before you do anything else is decide which way is positive. We generally make to the right positive. Now, you don't have to, but I'm pretty comfortable doing that, so I'm going to continue that process. And I'm just going to know that this is moving to the left, so this is negative, and this is to the left, so that's got to be negative. If you don't take that step, you're going to have a very hard time. So let's write out the equation. M1 V1 plus M2 V2 equals M1 V1 final plus M2 V2 final. We don't know M's, the masses, so I'm just going to use the symbol M, and this is 0, and then this one is M, and this is negative 5, and this is M, and this is negative 2, and this is M, and this is what we're looking for. Now, you know, if you've correctly labeled, then filling in the rest of this is super easy. It doesn't matter what subscripts you use, if 1 is 2 and 2 is 1, as long as you've included the right information. So this becomes negative 5M on this side, and this side is negative 2M plus M V2 final. So if I add 2 to this side, I get negative 3M equals M times V2 final. I want you to notice that these M's divide out on both sides, and I'm left with negative 3 meters per second is V2 final. All right, let's do another one. This one has a bullet, so let's label this M1, V1, V1 final, M2, V2, and V2 final. So a 35-gram bullet, so this is 35 grams. Strikes a 5 kilogram stationary block and emerges from the block at a speed of 87 meters per second. So that's how fast it is after the collision. and the block only moves at 8.6 meters per second. And we're assuming that the block starts at rest, and we want to know what's the original velocity of the bullet. So, first thing you should realize, right, is that the collision occurs right here, right, and that bullet passes through, and that the objects are going to move, right, this is moving to the right, and this is going to move to the right, so we're going to call those both positive velocities. M1v1 plus M2v2 equals M1v1 final plus M2v2 final. The other warning I want to give you is you have to watch the units. They have to be the same. Kilograms and grams are not allowed to be mixed. So to convert kilograms to kilograms, you move it 3 places. So let's make sure we change that. So we've got 0.035 times V1. This is 5 times 0. 0.035 times 87, and this is 5 times 8.6. So let's take out your calculator. 0.035 times 87, this becomes 3.045. You get this is 43, so this side becomes 46.0, this, and then this is 0.035 V1. So 46 divided by 0.035, you have an initial velocity of 1314 meters per second. It's a very, very fast velocity. Probably not really very realistic, is it? Considering that it's like 4 times the speed of sound. Okay, next problem. A 1,000-kilogram car traveling east at a speed of 15 meters per second has a head-on collision with a 4,000-kilogram truck traveling west at 10 meters per second. If the vehicles are locked together after the collision, what's their final velocity? So M1, V1, V1 final, M2, V2, V2 final. So we've got the masses, and it's originally going 15 meters per second, and this one's going 10. And we don't know what these speeds are. We just know that they're the same because they're locked together, so they'd have the same variable. You also want to evaluate the signs. This is going to be positive. This is going to be negative, so make sure you go in and fix that. So we've got M1 V1 plus M2 V2 equals M1 V1 final plus M2 V2 final. Now notice that because these are the same variables, you can combine these terms. So you get 15,000, and this is negative 40,000, and this becomes 5,000 V final. So 15,000 minus 40,000, you get negative 25,000. Be careful of the signs, they're important. And so you get negative 5 meters per second is V final. So the truck overpowers the car and they both get pushed back. Last example, a 7-gram bullet. So let's Okay, so let's fill in what we have. The bullet's mass is 7 grams, which is 0.007 kilograms. It's fired from a 4-kilogram gun. The gun is at rest when it's fired, and the bullet's in the gun originally, so it's at rest. The speed of the recoil just means moving backwards or bouncing apart, so we're trying to find that, the final velocity of the gun, and while the bullet moves forwards at 400 meters per second. So we can do M1 V1 plus M2 V2 equals M1 V1 final plus M2 V2 final. Both of these systems are at rest in the beginning. So the 4 times 0 plus the 0.007 times 0 Then you have 4 going at some velocity, and you have the bullet going at 400. So this whole side is 0, 4, and this is 2.8. And when you move this to the other side, you end up with a final velocity of negative 0.7 meters per second. And what that means is that the gun is going to have a slow, very slow speed, which we call kickback, in the opposite direction of the bullet. So I want you to notice something, kind of these different collisions. In the first collision, this is just a basic problem where you have two objects and they separate. This is, they have two different speeds at the end. They have two different speeds at the beginning. Okay. This example here is, again, you have two different speeds at the beginning. You have two different speeds at the end. Again, a pretty basic law of conservation problem, of momentum problem. This here, where the two things stick at the end, has a special name. This is called an inelastic. It's also a pretty basic problem, but it's a specifically a completely inelastic collision. And completely inelastic collisions, or perfectly inelastic collisions, are when things stick together and have the same final velocity. The last problem is an example of an explosion, which is just a completely or perfectly inelastic collision in reverse, where it starts at rest and then it separates into two things moving in opposite directions. So these are some very common types of problems that you will be seeing more of.